Okay, well, we're going to continue on with finding areas under curves, and today we're going to look at the trapezoidal rule. So you'll remember last time we were making little rectangles under curves. Today we're going to make trapezoids. Why would we do that? Well, let's take a look. I'm going to skip this top part for now. Let's go down and take a look at the same question, I believe, that we did last time, which is find the area underneath the curve y equals x squared plus 1 on the interval 0, 3, but this time we're going to use trapezoids. So I'll start just like I did last time by graphing it. So I only have to go from 0 up to 3, 1, 2, 3, and I have to go up to 10 along the left hand side. Okay, there we go. So let's graph some points here. If we put 0 in, remember 0 squared is 0 plus 1 is 1, so our first point is there. If we put 1 in, 1 squared is 1 plus 1 is 2, so we go there. If we put 2 in, 2 squared is 4 plus 1 is 5, so 2, 5 is a point. And if we put 3 in, 3 squared is 9 plus 1 is 10. So there are our points, and here is our curve. Now, what we did last time is we were making little rectangles under here, right? And they didn't really fit perfectly. Like when we did the right sum, this was our first rectangle, and look, there's all this space here that's wasted. It's like extra. We're going to get an estimate that's too high. But can you see how we could actually draw a different shape, which would be pretty close? We could draw a trapezoid. A trapezoid like this is pretty darn close to what the actual curve is. And we could draw another trapezoid here. Whoops, sorry. We could draw another one like that, and we could draw a third trapezoid like this. And wow, that's pretty darn close to what the curve actually looks like. Alright, that's the idea. So I can even show you the trapezoidal rule is an approximation of an area calculated using trapezoids. It's more accurate than rectangles like we did last time. In order to make this a little bit easier, I'm going to do a little bit of review on the area of trapezoids. So I'm going to start by drawing it like this. This is called a right trapezoid because it has a right angle down here. Not all trapezoids are right trapezoids, but the ones we'll be looking at will be, so might as well draw one of those. This is a right angle here, obviously not a right angle there. Now if I label these two parallel sides, see the parallel ones? If I call them A and B, the only other thing I need is the height. And the nice thing about a right trapezoid is the height is right here. So, do you know what the formula is for something like this? The formula is area of a trapezoid is equal to A plus B. You add together those two sides, the A and the B. You multiply that answer by h, the height, and you divide by 2. Okay? Now, if you look at that trapezoid there, it looks kind of different than the one we just drew there. The ones we just drew there. I drew 3 of them. Do you know why? Because we've kind of taken this one and we've tipped it up. So we're going to put the height on the bottom, and it goes up. I'm trying to draw the same size. I'm probably going to fail spectacularly. But this is supposed to be the same thing. You see how I've kind of tipped this up, and I've turned it into this one. So now my h, my height, is down here. The A and the B are here. And again, if you want to, you could draw your right angle, which I guess would be here. You also have a right angle there, of course. Alright, so we're going to look at our trapezoids this way. Because compare this, what I've just drawn, to the trapezoids that are right here, and I think you'll see they're pretty well similar. This bottom part here is like the height. Okay, so I'm going to give you the formula for the trapezoidal rule. There's actually a formula. It looks very complicated, but we'll go through it and you'll see it's not as bad as it might think. So we have b minus a divided by 2n, and then in a square bracket, because we're going to write a lot in here, we have f of a plus 2 times f of x1 plus 2 times f of x2 plus dot dot dot, we keep going, all the way to 2 times f of xn minus 1 plus f of b. And this is for the interval a to b with n trapezoids. So we've got quite a bit of explaining to do here, don't we? Alright, the first part I'll explain is remember we had, when we wanted to figure out the width of each one of our rectangles, in this case, in each one of our trapezoids, we used a formula which was change in x, the width, is equal to b minus a divided by n. Well, that kind of shows up right here. B minus n divided by n. We also have a 2 here, and we'll just talk about the 2 in just a second. Alright, so what's the rest of it saying? This is saying the function of the first value you're interested in, and then 2 times the function of the second one. I know it says x1. Actually, it might be easier if we call this x1, x2, x3. But because we're going from a to b, we're trying to show you that it's the first value here, second one, third one, fourth one, fifth, all the way to the second to last one, and then the last one is b, right? It goes all the way up to b. It looks confusing. You'll see it's not as bad as you think. Alright, so let's look at this and see if we can figure this out. The first thing we want to do is we want to figure out what's the width. Like, I drew these trapezoids. I just kind of assume that each trapezoid had a width of 1, but I should have actually done this first. I should have figured out the width. And how would I have done that? I would have gone b minus a over n, that's our formula. B is 3, a is 0, and we're going to do how many trapezoids? 3 trapezoids, so n is 3. Well, that equals 3 over 3, or 1. The width of each trapezoid is 1. Thank goodness I actually drew them all correctly. The width in each case is 1, 1, and 1. Okay, that's the first step. Now, let's solve this without the formula and see what we would do. So I'm going to rewrite the formula for a trapezoid down here. Okay, so the formula of a trapezoid we said is area equals a plus b, which is a little confusing because that's not this a and b, right? It's not the a and b that we have for our interval. This is a and b referring to the length of the parallel sides. We're going to multiply that times the height, and you're going to divide it by 2. So we got to get the area of each one of these trapezoids, and we'll add them together. Let's name those trapezoids 1, 2, and 3, just so it's easier to talk about. So to get the area of number 1, I add together the 2 parallel sides. Well, the 2 parallel sides are this one and this one here. And the nice thing about those lengths is they all end up at whole numbers. We have 1 here, and we have 2 there. So we add 1 plus 2. We multiply by the height, but wait a minute. You know what height is? Remember, height was along the bottom? The height is actually exactly the same as the x, the width. So, and we'd already found out it's 1. We're going to multiply by 1 and divide by 2. Okay, I'm not going to actually do that yet. I'm just going to leave that. For A2, what do? We add the parallel ones, which are 2 and 5 this time. It goes all the way up to 5. So we're adding 2 plus 5. We're multiplying by the height. Well, remember the height's actually the width, which is 1. And we divide by 2 again. And for A3, we add together the parallel sides, which are 5, and this one goes all the way up to 10, so 5 plus 10, multiply by the width, which is 1 again, and divide by 2. So if we want to get the total area, we would take this amount, add it to this amount, and then add that to this amount, right? We would be adding together all of this to get our final answer. Now let's just look at that for a minute. Do you see that in each one of the cases there is a 2 in the denominator? So we could factor that 2 out front. That's where the 2 shows up in the equation right here. Where did this 1 come from? Well, the 1 came from this, right? That's how we got the 1. We did the b minus a over n. So we can get rid of the 2 and we can get rid of the 1 because that is all this part out front. The b minus a over n is the width, which ended up being 1 in each case, and the 2 showed up in each case as well. So now the only thing left that we have to add together, if we factor out that top bit, is 1 plus 2, 2 plus 5, and 5 plus 10. So again, we're factoring out that 2, and we're also factoring out the 1 from each of these 3 cases, so we get 1 over 2 out front. Then what I still have left is 1 plus 2 plus 2 plus 5 plus 5 plus 10. Now, how does that relate to the formula? Do you see that the formula says the first thing you need is just f of a? Well, that would be f of 0 in this case, which is 1. So that is right here. Here it is. The next thing I want to do is go 2 times f of the next value. The next value is 1, f of 1 is 2, and you need to go 2 times that. Why do you have to go 2 times that? Because look, there's 2 of them, one here and one here. Right? It's the right hand side of this trapezoid, number 1, and it's the left hand side of this trapezoid, number 2. That's why it shows up 2 times. Next, you would do f of x2, the third point. That would be right here. And the output is 5. It says you have to multiply it by 2. Why do you multiply it by 2? Because it shows up 2 times. Why does it show up 2 times? Because it's the right hand side of the second trapezoid and it's the left hand side of the right trapezoid. And finally, you need to, we go all the way to the end now, there's no more points except the very last one, which was at B, or 3. And what's the output for that? 10. Notice we don't multiply by 2 in this one. How come we don't multiply by 2? Because that length is only the right hand side of one trapezoid. It's not the left hand side of another trapezoid, so it's just this. So again, this is why you're not multiplying the first one by 2, but you are for this and this, you're multiplying by 2. Alright, we might as well just finish this. 1/2. Now, 1 plus 2 is 3, 5, 10, 15, 25. So if you multiply that, you get 12.5 is our answer. I know this might be aggravating, but let's just do it again with the formula. You could do this without even graphing it. Okay, just to speed things up, here's the question. We're trying to figure out what the area is under the curve, and here's the equation. And I just want to show you, you can do this without even graphing it. So we've got A equals B minus A, well that's 3 minus 0, which is 3. 2 times N, oh, remember, I told us that N is 3. It told us that there's 3 trapezoids. So 2 times 3 is 6. F of A, that's the first point, that'd be 0. So f of 0, you put 0 in here, 0 squared is 0 plus 1 is 1, plus 2 times f of, remember our width is just 1, our width is 1, so we go up to 1, and we put 1 in here, 1 squared is 1 plus 1 is 2, so we put 2 there. Then we go to our next one, we've done 0, we've done 1, now we're at 2, 2 squared is 4 plus 1 is 5, so we need 2 of those. And now we come to the last point is 3. We don't need 2 of those, we just need 1 of those. So we put 3 in here, 3 squared is 9 plus 1 is 10. And we just have to simplify this. So A equals 3 over 6 is the same as 1/2. 1 plus 4 plus 2 times 5 is 10 plus 10. So A equals 1/2 times 5, 15, 25. Hey, what do you know? We got exactly the same answer. 25 over 2 or 12.5. Either one you want to write is totally fine. We got exactly the same answer. So that's how it works. You don't actually need to draw the trapezoids if you use the formula. Okay, just one question here. Approximate the area beneath y equals sine x on the interval 0 to pi using the trapezoidal rule with n equals 4 trapezoids. So first of all, we don't have to, but let's just do a little sketch to make sure we understand what this looks like. So here's 0, and here's pi, and we probably want to put pi over 2 over on here as well. It's a sine graph. Where do sine graphs start? They start at 0, they go up to 1, and they come back down to 0 at pi. So it looks like this. And I guess what I could do is also say that we're going up to 1 there. And what we're interested in is all this area underneath here. Okay. Now, if you want to draw the trapezoids, what you're going to need to do is figure out what's the width of each one. So how do you do that? You use the width formula, which is like this. So that's pi minus 0, that's your B and your A, and then divide it by 4, so you get pi over 4. Oh, that works out nice because pi over 4 is right here. There's 2 pi over 4, here's 3 pi over 4, and then we have pi. So if you were going to draw your trapezoids, they would look like, there's trapezoid number 1, actually looks more like a triangle, but it'll still work. Trapezoid 2, trapezoid 3, and trapezoid 4. But here's the thing, you don't actually even need to draw the trapezoids if you use the formula. So let me write the formula down again. Okay, here we go. So B minus A, we actually already did that, but it's pi minus 0. 2 times n tells us right here that n is 4. Now, f of A, that's our starting point, that's f of 0. So I'm actually going to write that down. We're doing f of 0 plus, I forgot my 2's here. I'm so sorry. So we're going to do 2 times whatever f of, what was the width? Pi over 4. So our next one starts at pi over 4, our next trapezoid. Plus 2 times, our next one's at pi over 2. So f of pi over 2. Plus 2 times f of 3 pi over 4. And finally we get to our last one, so it's not 2 times, it's just f of pi. That's what we have to do here. Alright, we can simplify the front here. We have pi on the top and 8 on the bottom. F of 0, well, what does that mean we're doing? We're putting 0 into the formula. So we're putting 0 in that x. We need to figure out what's sine x. I know you could skip some of these steps, but I just want to show you in great detail what we're doing. Then we need to do 2 times, we're putting pi over 4 there, so sine of pi over 4. Then 2 times, putting this into the formula, so sine of pi over 2 plus 2 times putting 3 pi over 4 into the equation there, so sine of 3 pi over 4 plus, not 2 times, but we're putting pi in there, so sine pi. Okay, so we'll leave the pi over 8. Sine, gosh, I'm really having troubles, aren't I? I was supposed to put 0 in here, since that's the first term. What was the x? What am I doing? So at 0 degrees, sine, or 0 radians, sine is 0. Plus 2 times. At pi over 4, that's 45 degrees, what's sine? Root 2 over 2. Plus 2 times. At 90 degrees, pi over 2 is 90 degrees, what's sine? It's 1. Plus, okay, we're in the second quadrant now. In the second quadrant, sine is positive. Nice, it's still positive, so we're good. 2 times sine of 3 pi over 4, that's a reference angle of 45 degrees. It's exactly the same as this one. Root 2 over 2. Plus sine pi, that's 180 degrees. Oh, sine's back to 0 at that point. Okay, so pi over 8 can ignore the 0. Oh, when we multiply this by 2, that cancels, and that'll happen here as well. So basically what we have is root 2 plus 2 times 1 is 2 plus another root 2. Okay, we're almost there. Pi over 8. 1 root 2 and another root 2 is 2 root 2. Plus, I still have that 2. See what you can do next? You can factor out a 2 from both of them. So factor out a 2 and you'll now have a 2 out front. And what's left is root 2 plus 1. But wait a minute, you got 2 over 8. You can put that in those terms. You get 1 over 4. But why not just write pi over 4? And often we'll put the whole number before the irrational number. So 1 plus root 2. This is your answer. So it's approximately 1.896. And we're done. By the way, I forgot to mention, go back here for a second. Remember when we got these answers here of 12.5? When we did this last time and we used midpoint sums, we got for this exact same question, we got that the answer was 11.75, and now we have an answer of 12.5. And if you want to know what the exact answer is, which we'll learn how to do soon, the exact answer is 12. So we are closer with the trapezoids. Not too much more, but we are a little bit closer. Trapezoids are preferable to the rectangles. Okay, that's the end of the video. Have a good day, and I'll talk to you soon. Bye.